Okay, good noon all. And actually, we have started a cogeneration and we have just crossed types of cogeneration, right? And started recording as well, right? But I didn't post it, right? So previous video lectures I didn't post it, right? So anyway, I'm just going to consolidate it and I'm just going to first in individually, right? So you could able to have a recording as well as PPT. No issues. I'm just going to post it today. I think 18 members joined, so remaining around 7 members need to join. So they will join later, right? I guess, right? And 19 members. Okay. I think my screen is visible, right? Yes, my screen is visible. And we have started a cogeneration and we have discussed about what is cogeneration. And I'm just going to recall it 1 second. We're just going to generate electricity as well as heat energy, so from a single source at the same time. Simultaneously we're just going to generate both power, and we are just utilizing both power at the same time in industry or maybe residential. So this is called industrial and maybe residential, right? So this is what a cogeneration, and we have crossed that principle. And that fuels which is now gas is going to use over here is now different varieties of fuel over here. So vegetable fuel, bioethanol, biogas, natural gas, coal, petrol, diesel, right? So we'll have flexibility, so we could able to use a number of fuel. And we have a number of conversion system, that is called IC engine, gas turbine, steam turbine, fuel cell, and this entire system is going to convert this type of fuel into heat and electrical power. And in traditional we are just only using electrical power, we are not utilizing heat as a customer. So we are just going to again depend upon electricity to produce heat and energy. But in cogeneration we are using both things at the same time from a single fuel source. And this are the common name is now burn energy once, you could use it twice. The twice the heat and electrical, right? So these are common small things. And the history we have discussed, and we have crossed compared traditional as well as this one, and different components we have discussed. So primary generator, heat recovery, steam generator and cooling tower, and control system. And in this we have crossed a topping cycle. Topping cycles in the sense we are just going to focus on generating electrical power, right? So in cogeneration means we are just generating electricity as well as heat. But in topping cycle we are much focused on generation of electricity. Also we are just getting heat and we are also using, but majorly we are focusing on generation of electricity. So on that case is called topping cycle. In bottoming cycle we are just going to majorly focus on generating thermal energy, that is called a heat. And topping cycle we have started combined cycle, and steam turbine we have crossed, internal combustion and gas turbine. So actually we have stopped with that internal combustion engine. So last class we have moved little fast. Anyway, I'm just going to start a small introduction about combustion as well as gas turbine, and we're just moving into bottoming cycle, and we need to go with that needs for that is called what is the factors which is required to make a 100% efficient cogeneration system, right? So we are just going to moving like that. So now I'm just going to move about a small internal combustion engine or a small introduction பார்த்துடலாம். Last class we moved a little fast, I guess, right? So time இல்லாதனால கொஞ்சம் fast போயிருப்போம். And now I'm just going to share that digital PowerPoint 1 second. I'm just looking for a tab, and the orchestra batch students are asking, right? So what's happening? I don't know. Mornings hour is not available. Okay, anyway, he told to join in our class. Okay, so I'm just 1 second, please wait, and I'm just going to convey a text message to orchestra batch students. Please be patient. 1 second. Now they will also join in our class. Our case are batch students also they will join. So anyway, they will join, and actually before joining, I need to post our classroom link. 1 second, please wait. What to do? Okay, anyway, I'm just going to post a Google Meet link. 1 second. Then only the people also could join. Okay. So they are just joining. They are all just getting joined, right? 40 members joined. Okay, let's get started, right? So last 3 classes we have discussed about combined cycle and steam turbine, and also we have crossed gas turbine. So gas turbine is one part of a combined cycle. Already we have discussed. Anyway, we are just going to continue, and we are just going to now move into diesel power plant. That's called a diesel generation in power plant. Right? We're just going to play it 1 second.
Engine, then the power station is known as diesel power station. Let's take a look at the diesel power plant. The various subsystems of a diesel power plant are prime mover, starting system, lubrication system, exhaust system, cooling system, air intake system, and fuel system. So let's learn about each of the subsystems in a bit more detail. In a diesel power plant, prime mover is a 2-stroke or a 4-stroke multi-cylinder diesel engine. The starting system. Starting system provides the initial rotation to the engine shaft required to start the engine. Smaller units can safely be started manually by hand cranking. However, larger units use compressed air for starting purpose. Lubrication system. Lubrication system consists of lubricating oil tank, pump, filter, and oil cooler. Lubricating oil is drawn from the oil tank by the pump and is passed through filters to remove impurities. Oil coolers are also there to keep temperature of the oil as low as possible. Exhaust system, as the name suggests, leads the engine exhaust gases out to the atmosphere. A silencer is used to reduce noise level. Air intake system intakes the air and supplies it to the engine for fuel combustion. Its air filters remove dust from air before forwarding it to the engine. Air filters can be dry type, made up of wool or cloth. Fuel system. Fuel system consists of a storage tank or the main tank to store the fuel. Transfer oil past another pipe called as overflow pipe is available to connect the day tank to the main tank. It returns the oil from the day tank to the main tank in the event of oil overflows. Fuel injection pump injects the fuel from the day tank into the engine cylinder at a high pressure of about 100 bars. Cooling system. Cooling system is instrumental for the liquid cooling process. In this system, cooling jackets are provided on the engine cylinder walls and head through which the coolant is circulated. The heat is transferred from the cylinder walls to the coolant by the process of convection and conduction. The coolant heated during its passage through the cooling jackets is cooled while it passes through the air-cooled radiator. So this is how a diesel density of these power plants is very high.
And what are the disadvantage and advantage of my diesel CHP, that is called heat and power transmission? A huge problem is that you couldn't able to increase your generated capacity about 15 megawatts, right? So if you could able to increase your generation capacity, right, so beyond the 50 megawatt, but if you're just going to increase the generation capacity, in the sense you are just going to increase your engine size, that is called horsepower of your engine, IC engine, you need to increase. So if you're just going to increase your engine size, definitely it needs a huge in bulk size. So definitely it needs to consume much fuel from your input. And if you're just going to increase your size of your IC engine, definitely that the heat is going to be much high, that efficiency also is getting down. So in that case, you couldn't able to generate much beyond that 50 megawatts. Generate பண்ண முடியாது. That's a more big issue in AC engine, internal combustion engine based CHP. And expensive due to the use of a diesel, because if we are using a gas or maybe natural gas or petroleum liquid petroleum gas as well as diesel, so that's called somewhat it's a day by day, you could see, you could have that knowledge, right? Day by day that the price of this fuel is getting changed, right? So that expense is little bit very high. So that's what if you're just going to move into a bigger in generation capacity machine, then it will be very difficult to use, right? And after 10,000 or 20,000 operating hours, right? So if we are having in our car, in our bike, right? So we are using internal combustion engine over there, and after 3,000 or 4,000 or 6,000 kilometer once, we are just going to change that liquid lubrication oil inside our engine. That's why its maintenance cost, it will be also applicable in this IC engine. So these are the some quite disadvantage about my diesel generator. But anyway, we'll have a number of advantages also over here, right? So these are the things which
Life of these power plants is relatively short.
anyway, these are the things about diesel internal combustion engine based CHP. And I'm just going to share my PPT 1 second. Deepak, we can leave, right? If I'm just having some test, right? So RFIP, RPFA, so you can go. So thanks a lot for joining. Thanks for right? Information, thank you. And we are just moving to PPT 1 second. Some people are having a placement, I guess. Now I just now started my window. Yes, my window is now started, right? And we have crossed combined cycle. We have crossed steam turbine, internal combustion. Just now we have crossed, and we have one more type called gas turbine, which is last type of my topping cycle. You could see last type, that is called gas turbine. Already we have discussed in combined cycle itself. Anyway, there is an individual point also there. Anyway, I'm just going to explain gas turbine once again, because we have just crossed about gas turbine in combined cycle CHP plant itself, right? So we have used gas turbine to generate electricity with the help of compressed air and natural gas combustion. And we used to heat recovery steam generator HRSC, and again we are just converted to steam. Again we are generated electricity with the help of turbo generator with the help of steam. This is called a two cycle power generation. This is called a combined two cycles we have used, right, to generate electricity. That's why it's called combined cycle. That's also we have discussed anyway. And individually there is one more thing is now available, that is called gas turbine. Anyway, I'm just going to within 3 to 5 minutes I'm just going to complete this gas turbine also. You could easily understood, right? Because already we have crossed. So this is what my combustion, that is compression chamber, and this is my combustion chamber. This is my turbine unit. So in compression area, we are just going to get air, and we are just going to squeeze it, and we are just going to compress this air with the help of a number of blades, right? And the air is now getting very we are just going to very hot air, in the sense we are just going to allow over this direction. And in this area I'm just going to allow gas, that is called natural gas or maybe liquid petroleum gas, right? So it contains, naturally it contains a chemical energy. Here thermal energy is now chemical energy is combined together, it form a, that is called combustion is now, that is called ignition is now happen. And here we'll have a turbine. So the ignited gas is now hitting, and the turbine is getting rotated. And that extra gases, exhaust gas is now coming this direction. We'll have a HRSG system and a steam conversion. It's now going. Right? Steam is now produced, and this entire shaft is now connected with my generator. Now once the turbine is getting rotated, that axis now connected with my axle is now connected with my turbine, is also now rotating this my alternator, and it's now generating electrical energy. So this is a way already we have discussed. That's why I'm just giving only small um, key point alone, right? So again I'm just going to show you small animation, about a 3 minutes small animation. You could easily have a visual over, right, how that gas turbine is now. 1 second is now how it's working. 1 second. Now my screen is visible to you, right? And now, so last time we have discussed about combined cycle with the help of Siemens gas turbine. Now we'll have one more leading company, General Electric company.
Air. A lot of gaseous molecules floating all around us. It's great for breathing, and it turns out it's great for getting lights turned on. That's because air, along with abundant natural gas or other fuels, are the ingredients that combine in a gas turbine to spin the generator that produces electric current. If you follow the electricity you use at home or at work back through the power lines to your local power plant, you'll see that the process most likely starts with the work of the gas turbine, the very heart of the power plant. First, air is drawn in through one end of the turbine. In the compressor section of the turbine, all those air molecules are squeezed together, similar to a bicycle pump squeezing air into a tire. As the air is squeezed, it gets hotter and the pressure increases. Next, fuel is injected into the combustor where it mixes with the hot compressed air and is burned. This is chemical energy at work. Essentially, this is what happens in your family car's engine, but at about 2,900 times more horsepower. Actually, it's exactly like the turbine engines on jet airplanes. The hot gas created from the ignited mixture moves through the turbine blades, forcing them to spin at more than 3,000 RPMs. Chemical energy has now been converted into mechanical energy. The turbine then captures energy from the expanding gas, which causes the drive shaft, which is connected to the generator, to rotate. That generator has a large magnet surrounded by coils of copper wire. When that magnet gets rotating fast, it creates a powerful magnetic field that lines up electrons around the coils and causes them to move. The rotating mechanical energy has now been converted into electrical energy because the movement of electrons through a wire is electricity. In what's called a combined cycle power plant, the gas turbine can be used in combination with a steam turbine to generate 50% more power. The hot exhaust generated from the gas turbine is used to.
So this way we already discussed, right? So gas turbine is now rotating this rotating generator, right? Rotating bit of alternator, right? Same way this exhaust gas is also getting here over here in HRSG system, heat recovery steam generator, right? Here due to convection, right, it's like a conduction, right? So now the heat is now transferred to my water, and it's now converted into steam. Steam is again is now feed over here. Now we'll have a turbo turbine that's called a turbine, that is called two-side generator, that is called a two-side turbines. It's called a turbo generator. It's very high speed. So now we'll have a generator in between over here, right? So if we are here, we are also connected over here. So this gas turbine also driving this alternator part, that is called rotary part, and also steam also is producing. The steam is again hitting this turbine, one more turbine, and this turbine is also connected with the rotating part. So here we will have a rotating thing over here also. Here this side shaft is driven by this gas turbine, and one more side of this rotor of my generator is driven by one more steam turbine. So you could able to have much rotational torque or much rotational twisting force is occurring on both side of my generator. So it shows that you could able to create much torque in both side. So it will give you that you could able to generate much electricity over here, right? So this is a combined cycle power plant also. Yes.
creates steam in a boiler, which then spins the steam turbine blades with their own drive shaft that turns the generator. What you end up with is the most efficient system for converting fuel into energy. And that's your GE Gas Turbine 101.
Okay, and these are all about a gas turbine. And now I'm just moving to my PPT once again, and we are just moving into next era. Now I'm just going to share my PPT once again. Yes, and I could see my screen, right? And we have crossed for different types of topping cycle CHP systems. So combined cycle, steam turbine, and internal combustion and gas engine. We have completely crossed the three that. And now I'm just moving into bottoming cycle. So bottoming cycle, in the sense, we are just now focusing on generating a thermal energy in a very high objective manner, right? So this is why it's called bottoming cycle system, CHP system. We're just now focusing on thermal energy generation at very high temperature, right? So here I could use heat energy, right? So we are just going to utilize the heat energy. If you are just going to create a heat energy for different types of process in our industry, it's not definitely required. So for the purpose, they people will use a boilers, right? So they will use a boiler system to generate a steam, right? So they will people many people they will use electric furnace, right? So we could able to generate heat thermal energy, right? So boiler we could able to use excess exhaust gas which is now coming from a turbine or IC engine. And the gas என்ன பண்ண போறேன் again நான் boiler கொடுத்து again I'm just generating a steam. That's called my uh, the steam generation is things called bottoming cycle, one of example. And what are the different types of industry they are mainly requiring a bottoming cycle system? So like a cement industry, steel industry. So steel industry, definitely you could have that knowledge, right? It needs much heat and thermal energy is now required in the steel industry, because they need to use raw materials, right? So they are just going to convert it into some shape of material, steel or paper, thin size or bar size of metal. They're just going to convert it raw material into, they're just converting this type of things, right? So for the purpose, they're just going to molding entire steel metals, right? So for the purpose, they need a very high thermal energy in nature. That's why steel industry, ceramic industry, petrochemical, diesel industry, diesel industry, and diesel petroleum and oil gas refinery companies, right? So in one more example that is called while coming into petrochemical or gas thing, right? So that is called refineries, right? So they will call this oil refineries. So you could have that, right? So I will have a crude oil, and we are having a crude oil. We are just getting that is called a petrol, diesel, liquid petroleum gas, LPG. So everything just we are just extracted from crude oil only. So crude oil வந்து எப்படி extract பண்றாங்க? By simply heating. So at various temperatures of heating. So in a particular temperature we are getting diesel. In different particular temperature of a thing we are just getting petrol and kerosene and LPG, right? So remaining on the tar, right? So at a different temperature treatment, temperature treatment only, we are getting different byproduct from a crude oil. So here that is called oil refineries. Definitely the major input is that thermal energy is much more needed. So like these companies, they will focusing on heat energy, right? So now I'm just going to move into CHP order. Why actually CHP is needed, and that's why we have discussed. And what are the disadvantage we have just somewhat we have just narrowed down in future. So not from here. And how we are just going to make a CHP as a what could I say, in a successful one. So if you're just having small industry in our area, or maybe we are just running small industry, or maybe we're just having any idea about CHP in our home. If we're just going to try to install a small micro CHP in our household applications, right? What are the things we need to consider to make our CHP as a successful one? So for the purpose, we are just going to see some of conditions. These are the famous somewhat they will ask some 8 mark question or 6 mark question. So mark படிக்க வேண்டாம். we'll go with some general thing, right? So we're just going to have a knowledge on over how we're just going to make CHP as a good one. So how we're just going to make CHP as a successful one in our home or maybe industry, because you are just now in a final year. So hereafter you people are ready to work in some industry, or maybe we'll have many options. We maybe if people may be joined in a good old industry janmalla, or maybe a medium scale industry, you could maybe join, or maybe startup company you could also join, or maybe IT industry they will also good ident to join. But in those company, right? So you will have this some knowledge, right? So how the company is running, what are the raw materials now coming, what are the products is now manufacturing, how it's right. So everything is now, if people now is going to be loan, right? Now, as a CHP, we have discussed a number of CHP, right? So, combined heat power system, uh, combined cycle, gas turbine, steam turbine, internal combustion engine based one. So, how now we are just going to make a CHP as a successful one, right? So, for that purpose, we need to focus on some criterions, right? So, it needs to meet some criteria. Then only we could call. Maybe then only we could able to make this CHP system as a what could I say, it's a meaningful one, as maybe successful one, right? So for example, I'm just to have a plan, right? For example, it's the first condition. For example, let us consider this my small home. Actually, I'm just going to have a plan to install small CHP in our household applications. In one more case, I'll have industry. So we'll have industry, right? So we are having a plan to install one more CHP, different types of CHP in my industry. So I'm just having a plan right now. So now, what are the things which is required to make CHP as a successful one, or maybe 100% useful one, right? First thing, right? For example, in my home, definitely I am just using electricity from a grid line, right? So the same way in industry also they will use a grid line. So electrical power supply, they for electrical motoring operation, or be it TV television in our home also, right? Many things. So if you are just to go with that, for example, if you are simply using electricity in your home, no need to go for a CHP. That's a best idea. If you are only focusing on electricity usages only, if you're having TV, a mobile, a laptop, a lighting system, or electric heater, right? So these are the application மட்டும் எனக்கு இருக்கு அப்படின்னா, and no need to go for a CHP. In industry also, if you're just going to run a motor, or if you're just going to run a lighting system for electric furnace, right? So I'm not getting any heating energy, right? And industrial எனக்கு heating energy தேவைப்படல. There is no requirement of thermal energy in my industry or maybe home. No need to go for a CHP. First point. இப்போ அந்த மாதிரி ரெக்குவயர்மெண்ட்டே இல்லாம, இஃப் ஐ ஜஸ்ட் கோயிங் டு பை சிஹெச்பி ஆர் மேபி வை சிஹெச்பி வேணாம் அப்படின்றனா, பிகாஸ் சிஹெச்பி இட் கன்சிஸ்ட் ஆஃப், ரைட்? ஸோ தீஸ் ஆர் த காம்பனன்ட்ஸ் ஆல்ரெடி வி ஹவ் டிஸ்கஸ். சிஹெச்பி இஸ் கன்சிஸ்ட் ஆஃப் அ prime mover. In the prime mover is nothing but my gasoline engine, IC engine, steam turbine, gas turbine. We will have varieties of prime mover. Fuel system, generator, because always common generator system, and HRSC, cooling system, control system. So it would cost higher thing, right? So it will be around 5 to 10 lakhs, right? Based upon my demand of my industry, it will be around 10 lakhs, right? So if you're not having any requirement of our heat energy in your industry or home, so no need to go for a CHP, right? So for example, in my home, I'm just going to use hot water for a drinking purpose, or hot bath watering water, or for a steam cooking. So steam cook or a steam cooker, right? So if you're having this much things requirement on home இருந்துச்சுன்னா, 100% go with that CHP also. In industry also, if you're just going with that steam application, right? So heating purpose, or a steam turbine based when you could be able to generate a power supply, right? If you're having a requirement about thermal energy in your home as well as industry, if you're having that requirement, definitely go with that CHP, right? The first condition, right? So the first condition is that you need to use both heat energy as well as electrical energy in our industry as well as home. If you're having both requirement in our home or maybe industry, in the sense, go straight away to CHP. This is the first condition. If there is any requirement of heat, எனக்கு heat energy requirement இல்ல அப்படின்னா, no need to go for a CHP. You could able to only have a power supply in from electrical grid. ஸோ ஏன் சார் சிஹெச்பிலேருந்து நம்ம எலக்ட்ரிக்கல் ஜெனரேட் பண்ணலாமே நீங்கள் ஒரு கொஷின்ஸ் கேட்கலாம், right? So for example, my CHP, right? So gas turbine or a steam turbine, for example, a combustion engine, IC engine. If you're having a CHP, this is called the prime movers. So gas engine, I'm just go with it, liquid petroleum gas. I need to buy it from a private agency or a government agency. Liquid petroleum gas. It will be somewhat quite high cost. As well as diesel for a IC engine, price will be very high cost. ஸோ இந்த மாதிரி கேஸில் ஒன்லி எலக்ட்ரிக்கல் எனர்ஜி மட்டும் நான் யூட்டிலைஸ் பண்ணுறேன்னா நீங்கள் எலக்ட்ரிக்கல் கிரிட் யூஸ் பண்ணிக்கோங்க. ஏன்னா கிரிட்டோட எலக்ட்ரிசிட்டி பில் பார்த்தீங்கன்னா இட் வில் பி சம்வாட் வெரி லெஸ் கம்பேர்ட் டு மை டீசல் பெட்ரோல் கேஸ் ப்ரைசஸ். ஃபார் எக்ஸாம்பிள், இஃப் யூ ஆர் யூசிங் ஹீட் எனர்ஜி இன் ஒரு இண்டஸ்ட்ரி ஆர் மேபி ஹோம் எனர்ஜி இன் த சென்ஸ், ரைட்? ஸோ அந்த கேஸில் அகெயின் நீங்கள் எலக்ட்ரிக்கல் கிரிட்ல எடுத்தீங்கன்னா ஃபார் ஹீட்டிங் பர்பஸ் அகெயின் ஐ எம் ஜஸ்ட் கன்சூமிங் மோர் எலக்ட்ரிசிட்டி ஃப்ரம் கிரிட். அப்படிங்கிறப்ப எலக்ட்ரிசிட்டி பில் வில் பி சம்வாட் வெரி ஹை இன் இண்டஸ்ட்ரி as well as home. If you're having CHP, இங்க ஹீட் வந்து உங்க எஸ்எஸ்சி கேசோலின் என்ஜின் ஆர் மேபி ஸ்டீம் என்ஜின் ஆர் ஐசி என்ஜின் itself it generating heat energy. And the heat energy you could able to use in our what you could say in our industrial home. So that's why the first important thing in our keep in our mind is that so we need to equally use heat as well as electricity energy. So in that case you can go with it CHP. This is the first condition. So the same way they just given this is a textbook, this is the content I just got it from our textbook, right? So for example they are just giving a university requirement as a college or a university or a school, right? So they are just requiring electricity, right? So pathina or college or school pathina definitely they will only go with it, electricity the maximize பண்ணுவாங்க because laboratory computer and classroom lighting and cooling system, right? They only go with it maximum electricity thing, right? So in summer time they will use cooling system, right? They will using a cooling system. So in university la pathina colleges or university they are equally use electricity as well as air cooling system. So அப்படிங்கிறப்ப you could go definitely CHP system is better idea, right? So based upon requirement only you are just going to buy or maybe install CHP in our industry or maybe residential applications, right? So அப்படி போறப்பவும் we need to have equally utilize heat as well as electricity. If you are using only electricity, go with that electrical grid electricity. If you definitely need heat energy or electricity ரெண்டுமே எனக்கு வேணும் அப்படின்னா just definitely go with it 100%. You could ensure that you could go with it CHP. So this is the first condition. So இந்த மாதிரி கண்டிஷனை நீங்க satisfy பண்ண மட்டும்தான் you could able to run our CHP in a good manner. So in second condition, your company it's now running under a very less profit, right? So if for example on worst condition company is now not running about 100% profit. In the case so no need to go for a CHP because CHP also because we need to purchase prime mover and gasoline engine or turbine and fuel cost, maintenance cost. This all it will be coming, right? So when you are just going to ready to install CHP in your company, it would cost, right? It would cost about 5 to 10 lakhs abina. Already my company is running at less profit. So again I'm just try to install the CHP about 10 lakhs 15 lakhs per unit of 5 to 10 lakhs na. Imagine if you are just going to buy five individual component in the sense 50 lakhs on the room. So it's not a good idea, right? So once your company is now running at a good profit, then you could able to CHP. So due to economic crisis or maybe overruling of your economies, right? So no need to go with that CHP because your company is already running in a not running in a good manner, right? That's why. So I say anyway, but even you could have that one more condition, right? In every industry will have a boiler. So right, so boiler pathina it's now going to generate a steam, right? So in the boiler input pathina we are having a fire that is called chopped trees or maybe a firewood, right? So that is called chopped trees as a fuel to my boiler, or maybe electric furnace we are just using to generate a steam, right? So for example your boiler is not run about 100% efficiency. If your boiler, even though your company is not giving the 100% of profit, right? So in that case I'm told that no need to go for a CHP, right? In that case right, so company is also not running at a good manner as well as my boiler, right? So it is a major important system in our company department. So that boiler is not running about 100% efficiency. In this case, go with that CHP. Got one more idea now? So உங்களுடைய இண்டஸ்ட்ரி பாய்லர் 100% ரன் ஆயிட்டு இருந்து 100% efficiency கொடுத்து company is not giving that much profit in the sense no need to go for a CHP, right? If for major part that I'm just giving as example, right? Boiler, right? So wherever a heating system is generating, so அது வந்துட்டு கரெக்டா ஒர்க் ஆகல அப்படின்னா, for example I'm speaking boiler, right? So we will have different section in our department, in our company. So each and every department is not giving 100% efficiency, then you could try to install the CHP on a particular system, not entire plant I'm not giving. So entire plant na solla, particular that section. So this is one more condition, right? So third condition, for example, I'm getting electricity from a grid, right? So to my industry, right? To my industry, I am just getting grid from electricity from grid also. I am also having a CHP in my industry, right? So this is now also generating electrical power. CHP also generating electrical power. But இதனுடைய fuel பார்த்தீங்கன்னா என்னுடைய industrial waste, day by day industry is now running. Definitely a number of wastage is now coming, bio waste, right? In the bio waste, I'm just going to convert it into biomass. Biomass is now converted to natural gas. Natural gas is now converted into electricity, right? So if you are having excess electricity, right? So because we are not buying any natural gas, LPG, petrol, right? We are only generating electricity and heat from industrial waste, right? So with minimum amount of installment of a price, now we could able to generate electricity as well as heat. In one case, if you are just generating excess electricity from CHP, so you are also using this electricity in our industry appliances. Even though you are having excess electricity, in the sense you could able to sell it, or maybe you could able to export into electrical grid. So in the case la, if I could, if we are just now getting a payback, now we are just getting a, because we are just going to export electricity energy to grid, we are just selling, right? So in this case, what actually we need to, as an industry person, what we need to do? For example, electrical grid la, I'm just consuming electricity energy, for example, per unit, right? So I'm just going to pay about 8 rupee, right? The same way now in my CHP, in my own company CHP is now exporting electricity to my grid. So on the case la, for example, I'm just getting paid about 6 rupee per unit அப்படின்னா it will be very good, right? So in worst case, எங்க எலக்ட்ரிக்கல் கிரிட் என்ன சொல்றாங்கன்னா, உங்களுக்கு வந்து நான் 4 ரூபி தான் தருவேன் ஃபார் யுவர் ப்ராடக்ட் ஆஃப் திஸ் எக்ஸ்போர்ட்டிங் திங். 4 ரூபி தான் தருவேன்னா, நோ நீட் டு செல்லிங் திஸ் export power, right? So instead of selling, you could reduce your consumption and you could able to use these CHP energy into your company. That's a good idea. So that's why we need to go with that legal binding documents. We need to go with that legal binding, right? So கண்டிப்பா நீங்க எனக்கு எவ்வளவுக்கு பெய்ட் பண்றீங்களோ அதே மாதிரி நான் செல் பண்ற எனர்ஜிக்கு யூ நீட் டு அட்லீஸ்ட் கிவ் 7 ரூபி ஆர் 6 ரூபி. ஸோ அதுக்கு கீழே போச்சுன்னா, ஸோ தட் என்டையர் ப்ராசஸ் இஸ் வேஸ்ட், ரைட்? ஸோ ஏன் லோ காஸ்ட்டுக்கு எனர்ஜி நம்ம செல் பண்ணணும்? ஸோ இன்ஸ்டெட் ஆஃப் செல்லிங், வி குட் யூட்டிலைஸ் ஓவர் இன் இண்டஸ்ட்ரி அண்ட் வி குட் டு ஏபிள் டு ரெடியூஸ் ஒரு இன்கமிங் எனர்ஜி. ஸோ எலக்ட்ரிசிட்டி பில் ரெடியூஸ் பண்ணிக்கலாம். ஸோ ரைட், தட்ஸ் த இட்ஸ் அ காமன் ஐடியா, ரைட்? That's why we are just going to go with it. So நம்ம மறுபடியும் எலக்ட்ரிக்கல் கிரிட்ல பவர் சப்ளை கன்சியூம் பண்ணாம, then you could able to use your CHP. Why we are just going to waste to என்ன சொல்றது, எக்ஸ்போர்ட் பண்ணி நீங்க லோ பிரைஸ்க்கு நீங்க செல் பண்றது வேஸ்ட், ரைட்? So this is a much more important thing in industry. Third case. And fourth case, right? So in CHP, we are using wastages as an input, right? So municipal waste, industrial waste, right? We are using this one, and we are just converting into heat and electricity, right? So some cases there is no municipal waste is not getting, we are not getting any waste, right? So now in this case we are using fuels that is called LPG or petrol or diesel, right? It will be natural gas, it will be somewhat price, it will be somewhat it's getting very high. So we need to consider your source fuel to this my CHP. We need to have a knowledge on my fuels, right? If you are having any wastages, right, vegetable waste, bio waste, right, nothing wrong in that, you could definitely use and you could able to generate. But instead of not having your biogas or bio waste thing, so in that case you need to buy a petrol, diesel, right? Definitely it will be somewhat, it will be quite high. So for this purpose we need to have major eye on my this source of my fuel, because it would cost, right? It would be somewhat, it would be very huge cost, right? So we need to focus on these sources of my CHP fuel. And last condition, so my last condition is that we are definitely getting electricity from a grid, even though some worst cases is now sometimes the electrical grid is now turned off, maybe some worst cases, right? So due to heavy environmental condition, maybe something is happened to this electrical grid. My industry is now again is need to run, right? So irrespective of my problem in my grid. So for that purpose, we need to install, right? So such a way that it needs to satisfy my entire load of my industry, right? For example, I'm just getting 2 megawatt energy demand from my grid, right? So in absence of electrical grid, this 2 megawatt installed capacity in my industry, it needs to satisfy, right? It needs to satisfy in such a way that we need to install small n number of CHP, micro CHP we need to install. So it shows that in absence of electrical power supply from grid also, my industry is going to be run with the help of my CHP, in such a way that we need to design CHPs and we need to install it many times, right? It looks like a standby mode. It looks like a backup power, right? Around 90% of energy it needs to be satisfied. So these are the 5 conditions. So in the 5 conditions satisfy the மாதிரி இருந்துச்சுன்னா, உங்க home needsக்கும் உங்க industry needsக்கும் இருந்துச்சுன்னா, your CHP is now 100% good application. So we need to focus on this 5 condition, right? So the satisfy பண்ணிச்சுன்னா, you could able to install CHP and you could able to run a CHP in a right manner, right? So these are 5 conditions. One thing I'm just recalling, both energy we need to use heat as well as electricity. And second case, if you are any department of your industry or home is not performing 100%, you can go with it to micro CHP in a particular section. And third one, we exporting electricity to the grid, right? We need to have a right idea, but how much energy we are just spend selling, as well as how much money is now we are getting, right? So it should be equal to what we are getting, what we are selling. It should be somewhat equal, right? So otherwise it will otherwise not used to export, right? And fourth one, we need to have an eye on our fuel, right? Because of CHP fuel, we need to watch, right? So என்ன மாதிரி fuel நம்ம யூஸ் பண்ணிட்டு இருக்கோம்னு பார்க்கணும். In the same way, fifth one, it should be irrespective of my input power from a grid, we need to have a standalone backup power to run my industry. About in 90% of backup and right? So this is a one more 5 condition, right? So we'll go with it some case study. Once case study is completed, we'll go with that energy management. So I'm just having 2 types of software. One is called Siemens or company software I'm just having, and we'll have a discussion over that. So cogeneration ஓட எனர்ஜியை எப்படி நம்ம மேனேஜ் பண்றது, எப்படி மானிட்டர் பண்றது, ரைட்? ஸோ ஹாவ் வி ஜஸ்ட் டிஸ்கஸ் அபவுட் டேட்டா எக்ஸ்பர்ட்ஸ் த சேம் திங். ஐம் ஜஸ்ட் கோயிங் டு இதோட உங்க சிலபஸ் முடிஞ்சது. பட் எனிவே ஐம் ஜஸ்ட் கோயிங் டு மூவ் லிட்டில் பிட் பியாண்ட் தட் லெவல், பிகாஸ் என்னுடைய சிலபஸ்லாம் பார்த்தீங்கன்னா புக்கில் மட்டும்தான் யூஸ் ஆகும். இண்டஸ்ட்ரிக்கு போகணும்னா ஐ நீட் மினிமம் எக்ஸ்ட்ரா நாலேஜ், ரைட்? ஸோ வி பீப்புள் நீட் டு மீட் ஆஸ் அ இண்டஸ்ட்ரியல் ரெக்குயர்மெண்ட். நம்ம படிக்கிற சிலபஸ்லாம் இண்டஸ்ட்ரியில் வெரி வெரி வாட் குட் ஐ சே, which far away. So we need to run a little faster to meet that industry requirement. That's why I'm just going to give you some of our software, some things, right? So for that purpose, I'm just planning about 2 software. We'll go with it in forthcoming classes. So before, and I'm just having a case study today. Before one thing, I'm just going to post our class attendance. Once again, please wait. I need to post attendance for the last hour layer. That's why. 1 minute. Okay, post it, and I will just continue. And now I'm just going to moving to some case study. Now moving to my one more PPT. Now I'm just moving to my enter screen. And you just confirm me, my screen is visible, anyone?
Yes, sir.
Yes, thank you. And in my future, right, so this is a case study which I just took it from online resources, right? So for in India, there is a huge opportunities for CHP. And 2013, right, so 2030 onwards, so 25% of total electricity is going to be CHP, because it's now evolving, right? So many companies are now ready, it's not ready, they already in the manufacturing side, right? So like Siemens, General Electric, many companies, unnamed, many companies are just started to manufacturing CHPs, because in a traditional electrical transmission, right, so only we are just transmitting electrical power, not heat energy, because in every household, right, every industry, we are using heating, right? So for boiling our morning coffee, tea, steam, right? So we are just using in number of heat energy. We are just depending upon electricity. So again, we are consuming much electricity. That's why if you're having our own CHP in our home with the help of vegetable waste, we are just going to generate electricity as well as heat. In the sense, why we are just not going to with the CHP? That's why in 2020, around 25% is not, it's more than it's going to be used now CHP. That's why. And this is the strength by using CHP. That's why we had just now we have discussed, right? You could have a fuel switching flexibility. It is called, you could able to use different types of fuel for a CHP, gas, petrol or diesel or vegetable natural gas. We could able to have that in number of option, and lower emission also. You could able to reduce your energy consumption by electrical grid also. You could able to reduce your energy cost, right? And you could also import our thing, right? So you could able to increase energy efficiency. Overall thing, it will be good by using a CHP. And what are the different challenges in CHP? In the sense, capital cost is much bigger here, because we need to purchase entire machine, right? We need to install it. That's why it's somewhat, it will be quite cost, and we need a infrastructural thing. We need to provide a space for a particular CHP, and they will have a somewhat regular maintenance and operations. And implementing strategy we'll see. And this is the first company. I'm just going to which I will just like to tell you. And in forthcoming class, I'm just going to give you one more company, sugarcane company. It will be very easy to understood, right? And this is one more company called Aravind Mills Cogeneration plant. And Aravind Mill is now one type of textile mill. And the total plant electrical power consumption will be around 27 megawatt actually. And this company actually required electrical power and heating as well as cooling. So I already told that if you're just going to have an idea to install a CHP in your plant, you should satisfy 5 conditions, right? So then only it will be a good choice to choose CHP. What is that? First condition, we need to use power as well as heating. That's why this company, that is called Aravind Mill company, also just looking for a CHP. If you're only having only requirement of power, in the sense, no need to go for a CHP. You can go with the electricity with the electrical grid. So this company, they just required about the heat, cooling as well as power. Then definitely they will go with the CHP, right? And investment in that company actually, that's a one olden company actually, and it's now 1996 la, they have installed about $50 million worth CHP in their company actually. And that project initiated by 1996, and it's now completed by 18 months. It will be around duration, it will be 18 months. After 4 years, that company has a payback period about 4 years back. Now the company is getting payback with the help of CHP. And you could see, we already told that, so that CHP is going to be generate steam as well as electrical power, right? So both of the thing is now used to reduce your consumption of electricity from grid. That's why they just narrowed down over here, right? So you could have that idea. These are the things we already discussed, right? And here they people two types of chp they have installed in their own company, right? So already we told that chp is now running under the principle of fuels also, right? So they have installed about two biogas fired plant in their company. So on the biogas la pathina, as a we already we told that five conditions we need to have, right? So a fourth condition it will be around what should I told already we have discussed about. So we should focus on what type of fuel we are using for that CHP system. So இங்க பாத்தீங்கன்னா they are using biogas that is called gasoline engine, that is called gas turbine CHP system. So அப்ப அதுக்கு என்ன fuel பாத்தீங்கன்னா natural gas we need to give it. But on the natural gas, how they just framing. So instead of buying diesel and petrol, they just looking for a rice husk from a rice mills, right? This is called somewhat price will be very low, right, compared to my diesel or petrol. Rice husk and baggage from sugarcane, and we're having n number of cotton waste and groundnut shell. So this all wasted which is now coming from entire different mills. So groundnut la pathina groundnut cell it will be getting wasted, and cotton mills it's now getting wasted, and sugar plant la bagasse is now from that is called after juice of sugar juice now will have bagasse that's called karambu chakkan சொல்லுவாங்க that one. And we're having a n number of wastages. This company they just looking for this different type of wastage in nearby that company. They just trying to buy this type of natural wastage, vegetable wastages. They are just collecting and they just storing in their company and making a natural gas, and then natural gas then just using this entire plant. So அப்படிங்கிறப்ப பார்த்தீங்கன்னா இதெல்லாம் fuel cost it will be very less. That's why these people company are just having that much profit, right? And now we'll see this CH plant will be around it's generating 90 tons of steam per hour. And this is actually this is not a thing, right? So they just missed about 25 megawatt power is now generated, right? But actually 25.7 megawatt per day or per month they are not just actually mentioned over here. So நல்லா வாட்ச் பண்ணி தெரியும் the CH plant is now itself generating 25.7 megawatt. And initially I told that the company itself around its maximum installed capacity or demand it will be 27. I already told that CHP நீங்க போறீங்கன்னா you need to use heat and electrical, as well as you need to focus on your what type of fuel you are using for CHP. We need to focus, as well as that if you are just in absence of electrical grid, our CHP itself it needs to meet your requirement. That's why CHP also 25 on megawatt power. So in absence of electrical grid also, with the help of your CHP also, you could able to run our industry, right? So these are the features about CHP in that company actually, right? So next one, I think we crossed 4 o'clock, and with that, I'm just going to wind up over here, and we'll have two more company. That is called one more company, DSL from Himachal Pradesh. We're just going to discuss about this company by forthcoming classes. I'm just going to wind up over here. Thanks for listening and thanks for attending. We'll meet by forthcoming classes. Thank you all.
Thank you, sir.
Thank you, sir.